All right, welcome back. On problem 83, you should have solved each of those quadratic equations, and you could have used algebra tiles or a diagram representing the tiles, and your answers needed to be in exact form. All right, so to start off, we're going to subtract 7 from both sides on this equation and get it set up so that we just have the x squared minus 6x, minus 6x equals negative 7. All right, to draw out the algebra tiles here, I would have an x squared tile, then I would have 3 negative x's above it, and 3 negative x's to the side of it. And this is equal to negative 7. And then I have to think to myself, what do I have to add in here to this square to make the whole thing a perfect square? And because this is a 3 by 3, I'm going to be adding 9 positive x's to both sides. So this dimensions now are x minus 3 and x minus 3. So I can write that as, in parentheses, x minus 3 squared equals negative 7 plus 9, or equals 2. All right, and we go forward on this one. We take the square root of both sides, and we end up on the left, x minus 3, and on the right, plus or minus the square root of 2. I'm going to add 3 to both sides of that equation to get x all by itself. And we get x equals 3 plus or minus the square root of 2. All right, so that's our first answer here. The next one, let me just make it bigger and scroll over. Okay. The next one, we're going to take away 1 from both sides. And we get p squared plus 2p equals negative 1. If we draw our algebra tiles, we'll have a p squared here. And then we have to break up the 2 p's into 1 each on either side. And this is equal to negative 1. And we have to decide, what are we adding here? Well, this will just be a 1 unit tile. And then our dimensions for this are p plus 1 and p plus 1. So we can rewrite this as p plus 1 squared equals 0. And if I take the square root of both sides here, we'll just get p plus 1 equals 0. Remember, 0 doesn't have signs. It's neither positive or negative. It's right in between those on the number line. And so we just get one answer. P equals negative 1. All right. And then for part C, I'm going to take away 9 from both sides. So we have k squared minus 4k equals negative 9. If I draw that with algebra tiles, I'll have a k squared tile. And I'm going to break up those negative 4 tiles into negative 1k, negative 1k. So negative 2k on top and negative 2k on the side. And that's equal to negative 9. Now I need to figure out, how do I make that into a nice, pretty, perfect square all the way around? And that means I have to add 4 unit tiles to both sides. All right, and my dimensions are going to be k minus 2 on both sides. So I get, in parentheses, k minus 2 squared as the area. That's equal to negative 5. Uh-oh. I cannot square anything and get a negative. So if I tried to take the square root here, I end up with no solution. All right, so you should have seen in this problem that it also asked you to tell me to explain how you can determine how many solutions a quadratic equation has once it's written in perfect square form. So that's our perfect square form. And if you look at the notes from the last section that you guys were supposed to copy down, oh, mine are gone. Just give me a moment. You could actually write this in a more formal way. So hold on just a moment and I'll pull mine up. Funny story, while I'm doing this, I recorded this whole video and went to save it and accidentally did not save it instead. So I'm doing this all over again because I love you guys. All right, so the general form of a perfect square quadratic equation is x minus p squared equals q. So what you could say, like a nice formal mathematical way to say this, is if q is greater than 0, that means if it's positive, then the solution, or the quadratic, has two solutions. Then there's going to be two zeros, two solutions, two x-intercepts. If q is equal to 0, then we'll have one solution. And if q is less than 0, or negative, that's another way to say negative, then there are no solutions, or 0 solutions. What that means on a quadratic, on a graph, if there's two solutions, that means our graph touches the x twice. It has two x-intercepts. If it has one solution, that means it's going to just touch one time. Oops, I didn't touch. Pretend I touched there. And then if it has no solutions, it's not going to touch at all. So you can see how that happens with quadratic equations when you have the graphs. All right, moving on. It says in problem 84, instead of using algebra tiles, how can you use an area model to complete the square for each equation in problem 83? So that'll be handy, as you're doing this. Maybe you don't want to draw all the algebra tiles, or maybe you don't want to get out the algebra tiles and you just want to think about this instead with an area model. So I'll show you how to do it for part A. So for part A, x squared minus 6x plus 7 equals 0. You're going to take away 7 from both sides, and we're going to end up with x squared minus 6x equals negative 7. All right, so instead of drawing the algebra tiles, then why don't we just draw a generic rectangle or a generic area model? So what do we have? We have x squared, and we have negative 6x. So we're going to break those in half, negative 3x and negative 3x. And then we have the negative 7 on the right. So then, we have to think about what we're going to add, but sometimes it's just easier to write out what we want the dimensions to be, and then think, what do I need to do to make that a perfect square? Well, x times x, x times negative 3x, x times negative 3x, that's good. And then this last piece, the part that we're going to add to both sides, has to be negative 3 times negative 3. Or negative 3 times negative 3, that'll be positive 9. So we have to add to make it into a perfect square. Remember, we have to add that to both sides. So from there, we write our perfect square form, and then we can solve it like we did in the previous problem. All right, so why don't we have our teacher pause this video for a couple minutes and let you just try part B using a generic rectangle instead of drawing all the algebra tiles. So you'll do part B, you'll do p squared plus 2p plus 1 equals 0 using a generic rectangle model instead of actually drawing all the little algebra tiles. Okay, so once you've had a chance to do that and practice that a little bit, let's go to problem 85. Problem 85, now we have Jessica, and she wants to complete the square to rewrite x squared plus 5x plus 2 equals 0 in perfect square form. First, she rewrites the equation as x squared plus 5x equals negative 2. So she subtracted 2 from both sides to get that number on the other side. But how can she split 5 x tiles into 2 equal parts? Well, she got out her saw. She's going to use force. She cuts one x tile in half and starts to build a square from the tiles representing x squared plus 5x. So what she's doing is she had 5 tiles originally, so there's 1, 2, 3, 4, and that 5th one she had to split it up because in order to make a perfect square we have to have the same number of tiles to the left of the x squared and to the bottom. Notice they just put their x squared on top here, so normally I do it on top of the x squared, but it doesn't matter. Alright, so the part A asks how many tiles are missing from her square. So here's what I like to do. I just like to draw across. Now we're using algebra tiles again, but that's okay. I'm just going to draw these out. Okay, so what are we adding to both sides? Well, this looks like a whole. These all look like whole unit tiles. And the reason I know they are is because of the dimensions, the base and the height of this tile is a 1 by 1. So these are all ones, ones, ones. So there's 4 of them right there. Alright, so I'm just going to keep track by doing this as we go. So I've got 4 tiles there. Now, the skinny tile right here that I'm highlighting in blue, so this one right here, has an area of 1 by a half. 1 times a half. So these are all halves. These are all halves because they're all 1 by a half. 1 by a half, 1 by a half. So what do 4 halves make up? 4 halves make up 2. Okay, so we can just write that as 2. And then this last one, this little skinny one in here, teeny tiny one in here, that I'm highlighting in purple, has a dimension of a half times a half. So what's a half of a half, or half times a half? It's a fourth. So we're also adding a fourth. So altogether, for part A, how many tiles were missing from Jessica's square? 4 plus 2 plus a fourth. Or we could say it as 6 and a fourth, or 6.25, or 6 and 25/100ths. How many unit tiles? 6.25. And then it says, help Jessica finish her problem by writing the perfect square form of her equation. So now the perfect square form of her equation is going to be x plus 2.5 squared. Those are the dimensions of her square. And that's going to be equal to negative 2 plus 6.25. Or another way to write it, x plus 2.5 squared equals 4.25. And we could go through and finish solving it from there by taking the square root of both sides. And it'll work. Just isn't as pretty as all the other ones. Alright, moving along. Problem 86. Now it's asking you to examine your work from problems 84 and 85 and complete the standard form of each equation. Excuse me, not complete. Compare the standard form of each equation to the corresponding equation in perfect square form. For example, compare x squared minus 6x plus 7 equals 0 to x minus 3 squared equals 2. What patterns can you identify? So from x squared minus 6x plus 7 equals 0 to its equivalent form, x minus 3 squared equals 2, what patterns are you noticing? And, does that pattern work for all of your problems that you've done so far in 84 and 85? I'll have your teacher pause it for a minute so you can investigate that with your team. All right, coming back to this. Some things you might have noticed. So this coefficient in front of the x, the -6, is always half of what the dimensions of our perfect square is going to be. Or excuse me, -6 is double. We have it to get the perfect square form. So we take that coefficient -6 and we divide it by 2. And that's how we split up our tiles. And that becomes our dimension for our perfect square. So that's one pattern you might have noticed. The other thing you might have noticed is what we're adding to the square. Let me go ahead and draw this as a perfect square. So we would have had x squared. And then let me just go ahead and do it in generic rectangle format. So that -6x we're dividing in half. And what you might have noticed is when we have that, we have to multiply -3 and -3. So we take that -6x and divide it by 2, and that's what goes inside here. And when we factor out, we end up with -3 and -3. So if we take -6 divided by 2, that -3 becomes what goes inside the square. And then what we're going to add to both sides is -3 times -3, or +9. So really what we're doing with that -6, we're taking half of that, getting that to be -3, and that's what goes right there. And then what we're adding to both sides of the equation is that -3 squared. So -3 squared ends up being what we add to both sides. So however you want to write down your observations for that, or however you already did write down your observations, that's great. Then I can explain it more when I come back on Monday. Okay, and the other example was if you want to rewrite x squared plus 10x minus 3 in perfect square form, what will the dimensions be? They'll be x plus 5 and x plus 5. All right, problem 87. I'm going to ask your teacher right now to pause this, and you guys are going to rewrite each equation in perfect square form and then solve it. Go ahead and you can use those patterns from problem 86. If they weren't quite clear to you and you weren't quite sure what to do, that's okay. But I'll ask your teacher to pause for a moment so that you can try these problems. All right, so I'll go ahead and do part A. First thing I'm going to do is subtract 52 from both sides. And then I know my dimensions inside my perfect square are going to be w plus 14. 28 divided by 2. Then I have to do 14 squared is what I'm going to be adding to both sides. And 14 squared is 196. And that's what I'm adding to both sides. 196 minus 52 is 144. Divide both sides by 2. And we get w plus 14 is equal to plus or minus 12. Yoo-hoo, that's nice. So w, I'm subtracting 14 from both sides. Negative 14 plus or minus 12 here. And so w is going to be equal to negative 12 plus 14, that's negative 2, or negative 14 minus 12, which is negative 26. So that's our answer for part A. Part B, x squared plus 5x plus 4 equals 0. On this one, you can do the perfect square, and it works. And I'd be happy to show you that sometime. But on this one, I know that factors. I've been factoring for a while, so I can just see that this one is going to factor. Because what two things multiply to 4x squared and add to 5x? X plus 4 and x plus 1. And when I set x plus 4 equal to 0 and x plus 1 equal to 0, I get x equals negative 4 and x equals negative 1. And that would have been the same exact thing you get from completing the square. Now, what's really nice about completing the square is that it works for everything. Factoring doesn't work for everything. You know, and actually for part A, factoring would have worked for that one as well. It would have, you know, what two things multiply to 52 and add to 28? It would have been 2 and 26. So, but you know, that's okay. All right. Part C, k squared minus 16k equals 17. All right, this one's already set up nicely for me. I don't have to add or subtract anything before I get going. So I'm going to put my perfect square dimensions in. So this is going to be negative 8. And then what two things do I have to multiply? Or do I have to add to both sides? What do I have to add to both sides? It'll be negative 8 times negative 8, or negative 8 squared. So it's going to be 64 that we add to both sides. That ends up being 81. And so we take the square root of both sides. K minus 8 equals plus or minus 9. So we're going to add 8 to both sides. So we get k equals 8 plus or minus 9. So k is 17. Or k is, oops, that should be a k. K negative 1. All right. Then finally, part D. X squared minus 24x plus 129 equals 0. All right. We're going to take away, subtract 129 from both sides. We get x squared minus 24x equals negative 129. And so my perfect square dimensions are going to be x minus 12 squared. And then I have to add to both sides to make that perfect square 144. Because it's getting late and I don't want to make any more mistakes tonight, 144 minus 129 is 15. All right. Square root both sides. X minus 12 equals plus or minus the square root of 15. Add 12 to both sides and we get x equals 12 plus or minus the square root of 15. Now all of these would have factored like I did in part C except for D. D would not have factored. But because A, B, and C came out to be integers, yeah, those would have factored. But you know, if you don't see it right away like I saw in B, completing the square always works. All right, well I hope this helped you guys, and I'll be happy to answer any questions. If you do have questions before this, you can post them on Google Classroom, and you can also go see any of the math teachers during tutorial. I hope you have a great weekend, and I'll see you on Monday.